Anthony, come on up. And then I need one piece of one? Yeah, one. Okay, you guys, on this question, you guys said that elements of the same group or family have the same physical and chemical properties. So let's look at 3 examples. Hey, what are we doing? We're going to look at 3 examples. We're going to look at 3 elements in group 1, lithium, sodium, and potassium. And we're going to look at some of the physical properties, and then we're going to throw them in some water and check out how they react with water, because that's also something they have in common. We go ahead and turn the lights on now. Unless we don't want to.
Yes.
It might be cool if we don't.
Well,
here's what we'll do. Jacob, you're the light person, so we'll turn them. We'll keep them on for physical properties, and then we'll turn them off for chemical. Yeah. I can't. Yeah, I wouldn't film it until we get to it. Why? We have tools here. Check this thing out. This is a bone saw. All right. Something about all these elements is that they are reactive, and they are so reactive that just to store them, they are stored in an oil or kerosene. So each of these will come in a tube like this, and there's a liquid in there. That's to keep them from reacting with the water vapor. Rosario, please separate yourself from everybody. No, you separate yourself from everybody, not you push everybody else. So come over here by Jacob. And I don't even know if it was your fault. All right. Thank you. Lithium is first, and it's a shiny metal, but it doesn't look all that shiny. It doesn't look very shiny because it will react with oxygen. So to see the shininess, we got to cut it. We're going to cut it. This is a metal. Why should I do this metal? Oh! Muscle. And what we can see is we can expose the lithium metal, and it is shiny. After a while, though, it'll turn into this dark gray color because it's reacting with the oxygen in the air to form or create a little tarnish. Soft metal, I mean, you can tear it, you can cut it with a knife, I can bend it. The ability to bend the metal is called what? Malleability. Very good, Jasmine. And then, the thing we're really checking for is, will it react with water? We're also going to put in a little bit of phenolphthalein.
Oh, pink.
Thank you there, Captain Obvious. Yeah, it is pink. You're right. We want it to be neutral, though. So there must have been some leftover base. This stuff is called phenolphthalein. Phenolphthalein is an acid-base indicator. And what it does, it detects the presence of different bases. Lithium hydroxide is a base, and hopefully lithium hydroxide will be created from this reaction. What happens is the lithium will actually tear apart the H2O of the water, and then it'll recombine. When it recombines, it gives off energy. So we're going to see, hopefully it'll give off enough energy to catch on fire. We'll see. It might not. First block it didn't happen, but we'll see. No, we're not going to do this whole thing. But check it out. It's making the lithium hydroxide. It's turning a pink color. Anybody have any idea what that smoke is? That is hydrogen gas. Hydrogen gas. Okay, I'm going to see if I can catch on fire now. Now. Do it. Do it. No. hopefully sodium will work. This is lithium metal. It's element 3. Element 3. Anybody researching lithium for their project? Highly reactive with water. It's almost out. Sodium is a lot very similar. Why is it similar to lithium? Paige, why are sodium and lithium similar?
I don't know.
I don't know either. What do we know about sodium and lithium though? They are both salts. They're both reactive with water. Why is that? Same properties because they're in the same what? Group or family. So this one, sodium, actually is softer than lithium. It's a silvery color inside. Looks kind of like Play-Doh, but it's not. This is a metal. Watch when I do this metal. You ready? Let me show you the arms when I do this. Are you impressed?
No.
There we go. Look at that. Muscle. That's what it takes. I'm going to throw the water back here. We'll see if it produces the base again, if it turns the water pink. And hopefully the sodium will ignite for us.
Hopefully.
Cross my fingers. Water. If it doesn't,
We have to do something.
then lithium or potassium. Sure. Hi. All right, we're ready to drop some sodium in? Yep, by the light this time, because hopefully it'll ignite. Not much, in the video we watched, listen, in the video we watched, she probably put in about 5 times, 6 times this much in it. So hopefully if we're lucky, it'll ignite. What's going to happen is the sodium is going to rip apart the water again, and then recombine. It'll make sodium hydroxide, and that's what's going to turn our water pink. It'll make hydrogen gas, which is the smoke we see. If we're lucky, the hydrogen gas will ignite. Here we go.
Nope.
Ignite! Boom! Give me the phone. And I breathe in the hydrogen gas, I can still taste it. It's not good. I did, I wrote it briefly. Go and turn the light on. Maybe you should put more in. Maybe we should.
Because you have a couple of pictures yourself.
This didn't happen. You didn't see this. What? No. Anybody ask? Do we need to get behind it?
Back.
Oh my God!
Read over the door. Rosario? Open the door. Whoa!
Hi there.
Put the whole bar.
That was good.
You wish, right?
That was not fun. Really? Why would I do that? That was me.
It's not silver colored Play-Doh, it is sodium metal. You guys ready for potassium?
Yep.
It's time to go big.
We're going bigger. Go bigger, go home.
Go big or go home.
Really? Oh, I'm saying really. Get that out of my face. I think you need a mask for this.
You're like 10 minutes.
It's only a minute Whoa. It was a little burst of flame.
Was it?
Yeah.
Alright, we have some potassium now. You two have your maturity caps on? Yeah. Are you being mature? Alright. Our last one is potassium.
Light.
Camera. On camera. Okay.
Hold on. Not quite yet. It's another silvery metal. We don't need as much potassium to get a reaction, but it is even softer than the first two. Even softer. It almost feels like sticky tack, kind of that consistency. Element 19, it also is going to make lithium hydroxide by tearing apart the water molecules. Hydrogen gas can be released. Hopefully, we get some flames. Now, if we get a flame, chances are it's going to be pink. Why is that?
Because of the hydrogen.
Because what?
Because pink's awesome.
Because pink's awesome, right?
Yeah.
But remember, we learned about how every element will burn a different color. All right. Light.
Camera. It was short-lived.
Whoa! That was cool. I don't have enough to do it again. I'm sorry. Wait. What did we look at? What properties did we see that all of them had in common? Vanessa? Vanessa doesn't know the question. What do you think that is, Vanessa? We don't just do this stuff for fun. There's science behind it. So we will come back to you. What properties did we look at that they all had in common? Cameron? What about hydrogen? They didn't flame. They were all what with water? Reactive with water. What other property? Anthony? They're all very malleable. Monica? Check that. Becca, what other property? What do they all have in common?
But they reacted with water.
We already said that.
They turned pink.
They turn the water pink, which means they create a base. Rosario, what other properties did they have in common? Remember, they were reactive with water. I heard that they formed a base, and I heard that they're all malleable.
Yeah.
What else?
There was fire.
We already said they were reactive.